When I got it, they gave me sort of a unique key. Said, here's your handle of this thing. You have to pass it back and say you've done that. And that will actually remove it from the queue completely. And their API, they've got an API that lets you sort of get the status of a queue. And one of the properties in the metadata that you can get back from that is how many hidden messages are living in the queue. So they'll say, here's how many total, or how many visible, here's how many that are sort of hidden or in process. And so I just then try to get another one to loop through. So nothing magic here, right? It's very simple. Their storage vectors are very easy. They've abstracted it very nicely. Let's see if there's anything else interesting in here. I don't think so. Let's step over to there. So we're going to look at here briefly at their. So that was, we looked at interacting with queues and interacting with blob storage of their S3 service. Looking briefly at their SimpleDB. Again, you create a client. You don't leave your keys on the screen. You instantiate a client object, just the same. They have this notion they call a domain name. Think about that as your worksheet name or your table name. I don't know why exactly they call it domain name, but that's what it is. It's your table name tool. You then scroll down, so here's some samples. And basically here you create an attributes request. So you basically, they call it a row as a collection of attributes. So I'm creating a new entry with the domain name, so I'm passing it the name. And then I set all of my properties on it. I want to use these attributes with these values, and then you just save that entry. That's basically what creating a row looks like. Now it's interesting, and the way it seems a little bit weird if you've not played with schemaless platforms before is you're like, shouldn't this be very structured? Well, I can have multiple entries in the same domain that have completely different attribute structures. So they've made it sort of overly generic, which in a way is weird if you're used to highly relational tables and so forth, but it's very easy to do. So here's, I just basically put it in, save it, and that's it. Now, in a separate application, a separate code over here that will read it. And it's very SQL-ish. So I simply create an expression, basically select star from experiments or whatever. You can do like operations. You can also do table limits. You can do limits on how many rows you get back at a time. Yeah, this notion, and this is true of both Microsoft as well, they have this notion of continuation tokens. So in order to keep you from creating a denial of service on their platform, they will only give you a certain number of rows at a time, both in the default, I think, to either 100 or 1,000. You can set it, you can change the value up to a certain amount, beyond which they simply say you have to request again. So you will always need to, if you're doing a lot of interactions, you always need to make sure, not only did I get results back, but is there a continuation token? Are there more rows available? And you'll see that when I get my response back down here, I basically, so I execute my response, and then I say, is there a next token, basically. So you can read it, and if it's null, I bail. If not, I read it again and add to my list. So that's probably the one big thing. Don't assume that what you got is all that there is. Make sure you go back and read. A couple minutes we've got left. Click through some of these things. We mentioned this earlier. Be careful with terminate versus shutdown. Key pairs are important. This last one I want to talk about just briefly. Parallelism can significantly improve your file transfers. So I actually have a blog post, and I'll talk a lot more about this with the Azure talk. But if you're doing large files and you really care about, you're really concerned about your speed, your transfer speed, chunk your data. You can see significant, and by significant I'm saying like 20 to 30 to 40 times speed improvements by parallelizing your uploads, even if on a given file, just using the standard .NET environment. Questions and answers at this time. That's my email address. Feel free to shoot me. I try to respond quickly. That's the website. I've got my blog and comments and so forth there. So I will later today, probably, certainly before the end of the day tomorrow, I'll be posting my slides and code samples So if you have any questions, you can look at that. Any questions? Yes.
Bottom line, how much is it actually going to cost for our instance?
So in true consultant fashion, the answer is it depends. And what I mean by that, it completely depends on your usage profile. If you bring up a small instance and run it for a month, it's going to be order of $87. Okay, that does not include transfer charges. So, and you say, well, how much are my transfer charges? Well, how much are you storing? How much are you moving? Right. So, the best thing is cloud services, both Amazon, Microsoft, and Rackspace, are not designed for your small website. So if you're hosting a website with, say, one-on-one and GoDaddy, and you're paying $15 a month, or $5 a month, or $10 a year, and you're happy, don't look at the cloud service. Stay there. These are designed for companies who have large burst traffic or scale traffic or need some feature. Now, that being said, my comment about CDN still exists. Right? The comment I made earlier about if you're sort of a small shop that you want to benefit from the content distribution network, I have a couple of small sites I run that they're perfectly happy at their regular hoster, but we wanted to do some CDN stuff. To actually host those files up in the blob storage and enable CDN. So that's, it's sort of an a la carte approach. You don't have to do everything in the cloud. You can do steps that way. But if you're a small shop, or if your site's happy on a shared hoster, don't look at it. You'll be frustrated with the pricing.
So as your site grows, you can gradually
you can move it. Right.
migrate over.
But it's really designed for someone who needs at least 2 or 3 servers, maybe periodically need 10 or 12 servers, depending on traffic. That's really the sweet spot of the model that you're targeting. It's not targeting your ultra small business. So if $86 or $200 a month for hosting costs scares you, probably not for you. And that's true of any of the cloud providers, not just Amazon.
So if you have a small website,
Yes.
basically it's just doing database lookups and things like that, but it also accommodates people uploading files. Would the right solution for that be to just keep your website the way it is and just use the S3 storage? to
There are
store
a
files?
lot of people who use that. There are probably a surprising number of websites that use S3 that you would never know. PhotoBucket, SmugMug. So SmugMug is a really popular site. All of your images are stored in S3. And we all know that because when S3 went down, SmugMug stayed up, and there were no images, right? So there's a number of sites that are doing it because that's a perfect example of where it's really great for this. They had no idea how they were going to scale. They didn't know if they were going to be big or small or what their demand was. And S3 gave them sort of this infinitely on-demand, growable storage space that they didn't have to think about. They just paid incrementally more, which is that's the perfect example, sort of the poster child case. Yes.
Have you have any experience with Google's cloud solution?
So no, and the reason I wanted to, and if you actually read the text for the project that I'm working on, we're supposed to. The problem is that this is all being done, all my work has been sort of in the context of scientific application and experimentation. And the way Google does, so Amazon is an IaaS platform. Microsoft is a PaaS platform, which we'll talk about in the next topic. Google is still a PaaS platform, but they're sort of at the top end of it. They have a very specific niche that they're saying, this is what we're good at, this is what our platform's good at, and if you fit in that slot, that's great. If you don't, sorry, we're not interested. And basically the niche they're targeting is highly scalable web apps. So if you're building an application, specifically for our requirements, they have a model that says every request has to finish in like 90 seconds or less. You can only pass a certain amount. It's like 50, it's not 50. It's a small amount of data per request. They're a very constrained model, which in the context of web applications makes a ton of sense. In the context of a scientific data processing application, it doesn't make any sense at all. So it's sort of what I was hinting at the beginning. You have to understand what